doing homework help with Jen. We're still in chapter 6. I'm going to look at problem 59 from the 9th edition, and I believe that's 57 from the 8th edition. And this, what you've got on your screen, is the problem that you're looking at in the textbook. Okay, I'm not going to read all that. What I've done down here is I have made a picture of it, because all my students know how much I like pictures. Okay, so what we need to do here is we need to set our Q's equal to each other. So we did a lot of these in class. This is just slightly different than the ones that we did in class. And what we would do is we would say that the Q value of our water is equal to the opposite of the Q value of our metal. Okay, because the heat lost by the metal is equal to the heat gained by the water. All right, so since Q is mass, I'll put this over here. Since Q is equal to mass times specific heat times delta T, we are going to use that information. And what we're looking for here is the specific heat of the metal. We have a mass for both, we have a starting temperature for both, we have a T final in this case, and we have specific heat for the water, which you can look up in a table if you don't remember it. All right, so we set this and we say, okay, well, the mass of my water is 150 grams, and the specific heat of my water is 4.18 joules per gram degrees Celsius, and T final is 18.3, and T initial is 15. Okay, T final minus T initial gives us our delta T. All right, now let's come over and do the metal. The mass of our metal is also 150 grams. They've made this easy for us. The specific heat of our metal is what we're looking for. And oh, I have run out of room, so I'm going to just tack this here. Then our delta T is 18.3 minus 75 degrees Celsius. All right. Okay, so let's sort of look at this and see if we can simplify it. One of the things we can do to simplify it is that since our masses are the same, we can just cross them out. They cancel across our paper. All right, so I'm going to come over here. So I'm going to merge some of these things. I have 4.18 times the difference of 18.3 minus 15. And that means that the left side of my equation is equal to 13.794. I will adjust for significant figures at the end. Okay, equals, okay, now I come over here and I look at the difference in my temperature here. 18.3 minus 75 is negative 56.7. And, oh, you know what? There needed to be a negative sign there because I needed the negative of Q of my metal. Okay, so negative 56.7 S of my metal. This problem isn't too difficult. It's just a little bit different than the ones that we did in class. Okay. These cancel each other out. I'm going to divide both sides by 56.7, and I will get that the specific heat of my metal then is equal to 13.794 divided by 56.7. And it looks like I can have 3 significant figures, so this will become 0.243 joules per gram degrees Celsius.